Now let's take a look at this example. First, this sequence, is there any patterns? So we can see this sequence starts with number 2, and you get each following sequence by multiplying by 2, right? So the multiplier of this sequence is 2. So we know this sequence is a geometric sequence because it has a common ratio of 2. So for geometric sequences, the explicit rule for finding n's term will be a sub n equals to the first term times the common ratio to the power of n minus 1. Okay. So first term is 2. And the common ratio or the multiplier, the constant multiplier is also 2 to the power of n minus 1. Okay. So if you simplify this, you'll get 2 to the power of 1 plus n minus 1, which is 2 to the nth power. So that is the explicit rule for finding the nth term of this geometric sequence. Okay, so with this rule, we can know that a sub 6 will be 2 to the power of 6, which is 64. And a sub 10, we replace n with 10, so that will be 2 to the 10th power. That will be 1024. Okay. A sub 20 will be 2 to the 20th power. That will be, this is a large number. Okay. So we can fill in the blanks. Okay. Now we want to find sum sub 10. This means the sum of the first 10th term of this geometric sequence. So how do we find this? Well, if we can find sum sub n, which is the sum of the first nth term, that would be helpful. So we know the general rule for finding sum sub n for geometric series will be the first term times 1 minus the common ratio to the power of n over 1 minus the common ratio r. Okay. So in this case, the first term is 2 and the common ratio is 2. So that will be 1 minus 2 to the power of n, 1 minus 2. So that will be -1. Okay, so that is the general rule for finding the sum of the first nth term of this geometric sequence. So the sum of the first 10th term of this geometric series will be 2 times 1 minus 2. So you got to plug in n with 10. So they will give you 2046.